how the world generates electricity? Right now, without you doing anything at all, electricity is flowing into your home. Through wires buried under streets, strung between towers, and running inside your walls, a continuous stream of electrical energy is arriving on demand, ready the moment you need it. You never see it being made. You never think about where it comes from. But somewhere, right now, a machine is spinning, fuel is burning, water is falling, wind is turning, and all of it is being converted into the electricity that powers your world. So how does the world actually generate electricity? The answer is more fascinating than most people ever realize. Almost all of the electricity on Earth is made using the same fundamental principle that Michael Faraday discovered in 1831. Electromagnetic induction. Move a magnet near a coil of wire and electrical current flows. That is it. That is the core mechanism behind nearly every power station ever built. The differences between a coal plant, a nuclear reactor, a hydroelectric dam, and a gas turbine are not really about electricity at all. They are about one thing only: what is being used to spin the magnet. The most common method for over a century has been burning fossil fuels. In a coal power plant, coal is pulverized into fine powder and burned inside a massive furnace. The heat from that burning coal turns water into high-pressure steam. That steam blasts through a turbine, a large wheel fitted with precisely engineered blades, spinning it at enormous speed. The spinning turbine drives a generator, a device built around Faraday's principle, where spinning magnets inside coils of wire produce a continuous flow of electrical current. That current travels out through transformers, which raise its voltage for efficient long-distance transmission, and into the grid. Natural gas plants work on the same principle, burning gas instead of coal to produce the heat. Together, fossil fuel plants still account for the majority of electricity generated worldwide, though that share is falling every year. Nuclear power works through a strikingly similar process, with one profound difference. Instead of burning a fuel, a nuclear reactor generates heat by splitting atoms. Uranium fuel rods inside the reactor core undergo a controlled chain reaction, where neutrons strike uranium atoms, causing them to split and release enormous amounts of energy as heat. That heat is used, just as in a coal plant, to produce steam, spin a turbine, and drive a generator. The electricity that comes out of a nuclear plant is identical to electricity from any other source. Only the method of heating the water is different. And because no fuel is burned, nuclear plants produce no direct carbon emissions during operation, which is why many scientists and engineers consider them essential to any serious plan for reducing the world's carbon footprint. Hydroelectric power takes a completely different approach. Instead of heat, it uses gravity. A dam is built across a river, creating a large reservoir of water held at a high elevation. When that water is released, it falls through tunnels inside the dam and strikes the blades of a turbine at the bottom with tremendous force. The turbine spins. The generator produces electricity. No steam, no burning, no nuclear reaction. Just the relentless pull of gravity turning falling water into power. Hydroelectric plants can also be turned on and off quickly, making them extremely valuable for balancing the grid during periods of high or low demand. Today, hydroelectric power is the world's largest source of renewable electricity. Wind energy operates on a principle that looks entirely different from the others, but arrives at the same destination. A wind turbine is essentially a generator mounted on a tall tower with large blades attached. When wind blows, the blades rotate, driving a shaft connected to a generator inside the turbine. Spinning magnets inside coils of wire. Current flows. The electricity enters the grid. Modern wind turbines can generate enough electricity to power hundreds of homes each, and offshore wind farms, built far out at sea where winds are stronger and more consistent, are now some of the most productive energy installations in the world. Solar power is the outlier. It does not spin anything. Instead, it uses a completely different physical process called the photovoltaic effect, discovered by French physicist Edmond Becquerel in 1839. When photons of light from the sun strike a silicon cell, they knock electrons loose, creating a flow of electrical current directly. No turbine, no generator, no moving parts at all. Solar panels convert sunlight into electricity silently, instantly, and at every scale, from a single panel on a rooftop to vast solar farms covering hundreds of acres of desert. Solar is now the fastest growing source of new electricity generation anywhere in the world. Here is what makes this whole picture extraordinary. Despite the enormous variety of methods, almost all of them are doing the same thing at their core. They are finding a way to spin a magnet inside a coil of wire. Coal plants, gas plants, nuclear plants, hydroelectric dams, geothermal stations, and tidal generators all operate on Faraday's 1831 discovery. Only solar breaks the pattern entirely. 2 centuries of engineering ingenuity, applied to a single physical principle, has produced a global electricity system so large, so complex, and so reliable that most people living inside it never give it a second thought. But the system is changing faster now than at any point in its history. Coal is declining. Renewables are surging. Batteries are beginning to solve the problem of storing electricity generated by the wind and sun for use when neither is available. The grid that delivers power to your home today looks nothing like the one Edison built in Manhattan in 1882, and the grid of 30 years from now will look nothing like the one we have today. The machines are different, the fuels are changing. But the underlying miracle, born from Faraday's experiment with a magnet and a coil of wire, remains exactly the same.